perpendicular distance. This is a formula you haven't learned in year 10, so let's go through it very carefully. Now, in this perpendicular distance formula, we need to use the general form. That's why we learned the general form. So basically, what we try to do is to work out the distance from a point to a line. Right? The distance from a point to a line is the perpendicular distance. Okay? Why do I find the perpendicular distance? It is the shortest distance to the line. Can you see why this is the shortest distance? Let's see. So imagine you have to cross the road. You want to go to the road opposite. So that's you over here. And then you're going to go there, go there. Which way is the fastest? Directly towards the line. Yeah, so right angle to the line. So that's how you get to the road fastest, is to walk directly at it. And that's exactly perpendicular to the line. Well, assuming that there's no car, okay? Well, you choose a road, there's a crossing. I'm just saying that that's the shortest distance. Okay. Okay, let's move on. This distance has a formula. And fortunately, it is on the reference sheet. Okay? All right, let's use this formula. So highlight this formula. It will be good to remember it, but if you don't remember, it is on the formula sheet. But you must know how to use it. Okay, so we're going to find how far is this point from this line. Okay? So what we do is this. So write D equal absolute value. That's where we use the absolute value in this formula. Square root. Okay, but you don't have to do anything other than turning negative to positive. Okay, now, this is what you do. You have to substitute that point into this line, right? So you write 3, 4, 5, but substitute 1, 4 into the line. Now, that's why in general form, we write the x before y, so that it's easier to substitute. We'll put 1 first, then 4. And then the rest is plus. Right? You substitute the point into the line first, in general form, of course. And then what do we do next? We have to square the 3, square the 4, the coefficient of x and y. Yep. Now, if you just press the button, you'll get the answer. Let's try that. So you go absolute fraction. Do you know there's an absolute value button? Yep, 3 times 1 plus 4 times ABS. All right, good. 24. Yeah. Gives the app, right? It's good. All right, that's the distance. Or in other words, that will be equal to 4.8. So the distance of that point to the line is exactly 4.8 units. Does that make sense? Sorry. Okay, good. No units, like it's not centimeters or meters, so we'll just say units. Yeah, or 4.8. Okay. All right, done. Next question. Show that these 2 points are on the opposite side of the line. All right, let me show you how that works. Okay, good. All right. So why are they on? So if I have this line, how do I know 1 point is on one side, 1 point is on the other side? How do I know that without even sketching? So there's a way to do that. Now let me show you. This is how it works. So you substitute 1, 4 into the formula. So 3x plus 4y plus 5 equals to 0. Let's substitute 1, 4. So right. Actually substitute this one first. So 1, negative 3. So let's substitute 3 times 1 plus 4 times that. Yes. Now work out what that equals to. So what would that be? 3 minus 12 is negative 9 plus 5 is negative 4. Okay, just leave it like that first. We'll just remember that's negative 4. And how about the other one? We substitute 3, 4, 5. And then you now substitute. Am I recording? Just double check. I have. That's good. All right. So you go 1 and 4. What would that be this time? That would be 24, isn't it? As we found earlier, right? Because it's 16, 21 plus 3 is 24. Okay. So basically, it is on the opposite side because 1 is negative, 1 is positive. Therefore, they are on the opposite side. Therefore, points on opposite side. Because they are different, like one's negative, one's positive. What if it's equal to 0? If it's equal to 0, you'll be on the line, isn't it? It satisfies the equation. If they're both bigger than 0, they're on the same side. Or they're both less than 0, both the lines are above. There's only one line. You've got nothing with quadrant. So as long as one's negative, one positive, there you'll be on opposite side. That's still on the same side. So if I draw this, that's still on the same side. Yep. Yeah. All right, I think I understand. Let me try this. So you were saying, let's say the equation of the line is y equal to 3. Is that what you mean? And then you have a point here which is 1, 2. The other point is, what's the other point? Say negative 2, 5, right? Okay, good. So you have to put that in general form, which is y minus 3 equal to 0. And then you substitute. If you substitute 2 in there, what do you get? You get negative 1, negative. If you substitute 5 in there, what do you get? You get positive 2. So they're still opposite. 1 positive, 1 negative. Get it? But you will be. But you just told me one's below, one's above. So you will always work. It's been proven rigorously, so you will be guaranteed. If you can find a counter example, I will give you 100, but I'll give you $1,000 if you could give me an example that this doesn't work. Yeah. Well, find one first before we sign it. Okay. Yeah, it's just recorded. Yeah. All right. You can bring. All right. Okay. Now watch this. Okay. Let's move on. Find the distance of the point from the line. Okay. Let's find the distance of the point from the line. Now, what do we do first? You have to put in general form. Well, minus 3 is 0. Thank you. All right. Now, we have to find the distance. So what you do is d equals, write in general form, 5 minus negative 3, and substitute 1, 4 in here. So put 1, 4. And then you go f square root of 5 squared plus negative 1 squared. Okay? Leave your answer in exact form because it's going to be a third this time. So you get root 26 at the bottom. The top will be 5 minus 4 is 1. 1 minus 3 is negative 2. That's why we need absolute value to turn it into positive. That's what the absolute values are used for. Right, that's the distance. Any questions? Oh yeah, you could, but you will give you a decimal, right? So say I did this. Yeah, but I'm just prefer to having exact form. So if I do this, negative 2. No, but you better to put in decimal. But it's not exact if you round it. So unless the question asks you to round, otherwise you should put in exact form. Okay? All right. Thank you. That's good. Let's move on. 2 more pages. That looks hard, but it's actually quite easy if I show you the way. Yeah, I'll show you the fast way, the express route. You write it down. Can't be bothered. Alright, let's move on. Okay, prove that this line is a tangent. So if it's a tangent, now this is a circle, right? Let's draw the circle. What's the radius of the circle? Very good. Tangent. Well, a tangent is something you've learned since year 7. What's a tangent? A line that touches at one point. That's a tangent. And the secant is something that crosses at 2 points. And then there's line that doesn't cross at all. That doesn't have a name. They don't have any names. Just a line. Yeah. Okay, now watch this. Tangent. So to prove it's a tangent, all you have to do is to find the distance of that line from the center of the circle. Okay? Now the center of the circle is 0, 0, right? That's the center. Let's work out the distance of that to this line. Okay? So use the perpendicular distance formula. 6 times 0 plus 8 times 0 plus 20. Find the distance of that 0, 0 to the line. 6x plus 8y plus 20 equal to 0. Okay? Go over square root of 6 squared plus 8 squared. Alright, use your calculator or this line, right? That's the line. Now that's the distance we'll try to calculate. Oh, oops, sorry. So I'll write it again. 6 squared plus 8 squared. Okay, do that. Do it on your calculator. See what you get. You should get 20 over 10. You should get, because I'm finding the distance from the center to the line. Yeah. So this is basically, let me write a note there. Distance from the center of circle to the line. Okay? Alright, what answer did you get? 2. And this is same as the radius. When the distance is same as the radius, we can be sure it must touch the line at one point. But how do you know it's going to be 2 until you calculate it? Well, you say you have to prove it. You have to prove it. So you have to show it's a tangent. So you say, therefore, line is a tangent. Does that make sense? No, you can say, oh yeah, you should. So that will know we're verifying that the distance from the center to the line is same as the radius. Therefore, the line is a tangent. Alright, so it's very easy. That's a good application of that. One more thing I want to say. Let's generalize this. So if it's a tangent, we'll know tangent if the distance is equal to the radius, right? What if it's a secant? Or basically intersect at 2 points. So intersect 2 points. What would we call this? I know, but what would it be like? Intersect at 2 points. Can this line? It will be that means the distance will be less than the radius, right? Can you see when the distance is less than the radius, it will cross at 2 points. And if it doesn't intersect, let's put a different color, does not intersect, what will happen? That means D has to be greater than R. So you just have to remember all this. So, yep, I'll make it bigger. Too small. If it's this distance less than the radius, right? We'll cut at 2 points. And if the distance exactly the radius, it will touch at one point. And if the distance more than the radius, it will not touch at all. No. Just a line. Yeah. Alright, any questions? Alright, leave it there. Thank you. And one more. Right. Oh, very good. Yes, fast. Secant. Actually, we actually learned that. Remember sec theta? That's secant. Secant theta. Comes from the word secant. And remember tan? Remember tan theta? That's the tangent. Right. Alright. Alright, let's move on. Have you all finished? Finished? Yes? Let's do another example. This one needs some algebra. Algebra. Okay, now, how does that work? This one, they give you the distance is 5, right? And they don't tell you what k is. You have to find out what k is. Now, let's use the formula. So origin is 0, 0. Let's find the distance of the origin from the line, which is 3 times 0, 4 times 0 plus k, over square root of 3 squared plus 4 squared. Yes? So your expression will be in terms of k. Alright, so what do we have? So you get absolute value of k over 5, right? And they say that distance is 5. That distance is 5. Now we have to solve for k. Yeah, so distance is 5. 3 squared plus 4 squared is 25 squared. Good. 25. So what would k be? Very good. Ah, that's good. Very nice. So when it's an absolute value, you put a number, it could either be positive or negative. Yeah. So what are the possible values of k? We found both. That's good. Any questions? Pretty easy, isn't it? When's T day? T day will be...
Oh no, I'm away. Next week.
Why will we be away? Oh. Let me see. T. Let me think. Ah. Excellent. Beautiful. That's cool. Okay. Next week. All right. We always have maths on Monday. All right. Let's move on. Maybe. All right. 2 units. Okay. Let's look at past HSC questions. Next question. Okay. On this diagram, there's a quadrilateral. The equation of the line AD is shown, which is written over here. Show that it's a trapezium. How do I show this is trapezium? Show that the lines are parallel. How do I show they're parallel? Find the gradient. Find the gradient of BC first. What's the gradient of BC? Gradient formula. And what do you get? You get 2 over 1, 2. How about the gradient of AD? What do? You make y the subject, right? So if you make y the subject, which is 2x minus 1, what's the gradient of AD now? Gradient of AD equal to 2. Because we want to prove that parallel, right? That's 2. Well, if they're parallel, the gradient must be equal. Yeah, okay, so therefore you write and BC just need more revision. Therefore, BC parallel to AB. Therefore, ABCD is a trapezium. It's all deduction. Therefore, it's a trapezium because you have one pair of parallel sides.
Therefore,
Okay, done. It has to be. Trapezium doesn't have to. That's a trapezium. It can be called trapezium. Yeah. It can still be called trapezium. Yeah, but trapezium is not rectangle. Okay, let's move on. I don't even know what that is, but anyway. Yeah, that's it. Easy. Excellent. That's it.
so rectangles are what?
Yeah,
Rectangles is everything.
everything.
Shape system.
All right. Next one. Line CD is parallel to x-axis. Find the coordinates of D. Okay, move on. All right, we're going to find the corner of D. Now, notice this is parallel to the x-axis. Now, how does that clue help us to find the corner of D? Any suggestion? No? No? Try to avoid trigonometry here because it doesn't work on number plane. Okay, now, watch this. If it's, notice this is a horizontal line. Do they have the same y value? That's exactly what we need. Substitute y into this formula. See, this line passes through D. So substitute y equal to 5 into 2x minus y minus 1 is 0. So what do you get? 2x minus 5 minus 1 is 0. If you solve it, x equal to 3. So we got the corner of D, 3, 5. Now we get to use perpendicular distance. Soon. Okay, let's find the length of BC. How do we find the length of BC? What formula do we use? The distance formula. So we go 5 minus 3 squared plus 1 minus 0 squared. Leaving exact form if it doesn't say to round. So it's 2 squared plus 1 squared is root 5. Yep. And then we have to find the perpendicular distance from B to AD. Let's draw this. Perpendicular distance from B to AD. This distance here, right? So how do we find that distance? Yep. Is to, well, what's the corner of B? B equals to 0, 3. And what's the equation of AD? In general form is this. Now you just have to use the perpendicular distance formula, work out the distance. And then you leave it in exact form again. What do you get? They say to show this, so you get negative 4. Negative 1 square. Let me write it again. Hey, what are you doing? You'll, yeah. Yeah. Oops. Yeah. No. Yeah. Yeah. Okay, so they give you the answer. You just have to show that it works. All right. Okay, now we have to find the area of the trapezium. Have a look at the diagram. So notice that this is called corner geometry. We can find our area, length, parallelogram, or trapezium using all these equations and formulas. Okay, using just coordinates. Okay, now what's the length of BC again? Root 5. And we know the distance is 4 over root 5. Yep. Yep, go down. Now we're going to find the area. Which school? Which one? Which school? Okay, let's move on. All right, let's write down this. 4 over root 5. All right. Okay, now to find the area of the trapezium, what do? A plus B times the perpendicular height. Remember the area of the trapezium? H over 2, A plus B. Now, do we know A and B yet? We already know the perpendicular distance, which is half times 4 over root 5. One of these is root 5. What's the length of B? Yep. No, just leave it like that. See, even the question didn't rationalize. Okay. Yes, let's find the distance AD using the distance formula. So remember what D was? 3, 5. A is, and then you find the distance. So you go 3 minus 0 square plus 5 plus 1 square. That will be 9 plus 36 root 45. Right? That's the distance from A to D. All right, we'll find the length of AD. Find the length of AD.
Why are we doing that?
Well, okay, let's draw the trapezium. Okay. Now what's this? Okay, now how do we find the area of the trapezium? Okay, H and A and B. Now, do we know the length of A? A is root 5. A is CD, right? Yeah, BC. And what's the length of B? We don't know. That's what we'll try to work out, the length of AD. And do we know H? We found out in part 4. 4 over root 5. So we got all 5 things. Does that make sense? And then you can simplify that to be 3 root 5. So write 3 root 5 here. Okay, and then you can simplify that. So the 2 cancel with the 4, which is 2 over root 5, multiplied by root 5 plus 3 root 5, 4 root 5. And then you just have to cancel the root 5, which is just 8. That's the area. Unit square. You're right. That was simple, but all right. Okay. Okay. All right. Yeah, one of the easy